Well, good morning once again, pre-calculus students. Let's go ahead, let's take a look at today's work, which is going to be continuing on in 9.3, where we are going to look at specific types of sequences, namely arithmetic and geometric, amongst further looking at finding different ways to define sequences. So let's go ahead and let's start off here. So the first thing we're going to look at is what is an arithmetic sequence. So essentially an arithmetic sequence is one where we add a common amount, or we call it a difference, to each term to get the succeeding term. So in other words, it's something like we add 5 halves each time, or we add 2 each time, or we add -3 each time. And whatever that common amount is that we're adding, we call it a difference because it becomes the difference between 2 successive terms. So for instance, if I'm adding 2 every time and I start with 1 and I go like 1, 3, 5, 7, something like that, well, the difference between 2 terms would be 2. So we call that common amount that we add a difference. Now, if we want to define an arithmetic sequence recursively, what we do is remember recursive definition, we start by defining the first term, and then what we do is any successive term is simply defined by whatever the previous term was. So a sub n being any term a sub n is defined by the previous term plus our common difference. So when we go to do this, let's look if we have this sequence here. So we're going 1, 4, 7, 10. So we see this is arithmetic. We are going up by 3 each time. So that's a common amount we're adding each time. So when we go to define it, we define the first term. A sub 1 is 1. And then we define this by simply saying that any other term, a sub n, is the previous term plus 3. And we do have to start with n. That starts with n being 2. So in other words, that starts our second term. All right, so let's go ahead, let's look at defining one explicitly. So it's a little bit more difficult to use the explicit rule, but the explicit rule becomes more valuable because we can instantly find something like the 100th term. So explicitly what we do is we define any term a sub n, not in terms of the previous term, but in terms of n, just what number of term that is. So what we have to do, our rule is this, and this is a rule you're going to have to know. We start with our first term, and we add to it n minus 1 times d. So for instance, and that's for any n greater than or equal to 1. So that defines the first term of 1. It defines any other term. So for instance, if I'm going to define the previous term, notice I would have a sub n, or the previous sequence here. I would have n minus 1 times my common difference here would be 3. Now normally we don't leave it in this form here. Normally what we're going to do is we're going to distribute this 3 through and write this in a form we're used to seeing. So if I distribute the 3 through there, I would get 3n minus 3, and if I add 1 to that, that becomes the minus 3 becomes a minus 2. So we normally would write it in this form here. Notice we can see, so for instance, if I want the 4th term, I put 4 in here, and I would have 3 times 4 for 12 minus 2 is 10. And if I notice, I see my 4th term is 10. Obviously, it's easy to find that with the recursive definition, but if I want the 100th term, pretty easy to find it here. 100th term would be 300 minus 2, so it would be 298. Much easier than finding the 100th term if I was going recursively. So that's explicit. Now let's talk about the geometric sequence, the other type. We said we're going to talk about arithmetic and geometric. Now we're going to look at geometric. And remember, if I'm going a little fast for you, just pause the video and finish writing down what you need to write down. And if you need to hear something again, simply go back and re-listen to it. So our geometric sequence is similar to the arithmetic, except that we're doing now, instead of adding a common amount each time, now we are multiplying a common amount. So we multiply each term by a constant, or we call it a ratio, to get the succeeding term, because that constant value becomes the ratio between two terms when we compare two terms. So for a recursive definition, what we do define the first term. That's always given. We define the first term, but then our nth term would be whatever our previous one is, our n minus 1 term, times our common constant, our r, which is our common ratio, what we say. And so we define r as being the common ratio there. So let's look at a geometric sequence. So here's our geometric sequence. We'll call g of n here our sequence: 2, 4/3, 8/9, 16 over 27, 32 over 81. Now, you may be even asking, do I even know this is geometric? How do I know it's geometric? Well, one way you know it's geometric is I told you that it's geometric, but the way to figure it out is to take multiple terms and see if there is a common ratio between terms. So for instance, if I look at this and I take 4/3 over 2, and I looked at what that ratio would be, if I take 4/3 divided by 2, that would be multiplying by 1/2, which would make 4/3 times 1/2, which would make it 4/6 or 2/3. So 2/3 is the ratio between these two terms here. If I compared these next two terms, and I said I'm going to take 8/9 divided by 4/3, well, that would be 8/9 times 3/4. And if I reduce that down, I find I get 2/3 again. So notice that each term here is 2/3 as big as the previous term. So I do have a common ratio, so it is geometric. And I know that common ratio is 2/3. So let's define it recursively. First term is 2. And my common ratio is going to be 2/3, so it's going to be the previous term. Any g of n will be the g of n minus 1 times 2/3. And that's for n greater than or equal to 2. Because obviously the first term, n of 1, is just defined outright. Now let's look at an explicit. Explicit, we follow kind of the same process we did with arithmetic. We know that our general nth term will be equal to whatever our first term is. Now, instead of adding, we'll multiply times our r, and instead of multiplying by our common difference, now what we do is we take the n minus 1 and we raise it to the n minus 1 power. And that's for n greater than or equal to 1. So that gives us our first term, n of 1, and each successive term. So if we look at this term, if we want to express this sequence here with an explicit definition, notice we have our first term, 2, goes right here, our g1, our common ratio of 2/3, and we raise it to the n minus 1 power. We can check and see. Now, if I want the fourth term, I would put a 4 in here, and so I would raise this to the third power, which would be 8 over 27, and when I multiply it by 2, I would get 16 over 27. That is my fourth term. Notice my first term, if I put a 1 in here, I'd get 2/3 to the 0, that'd just be 1, so I'd get 2 times 1, I'd get 2. And you can check it for any other one, it will work. Now obviously, doing the 100th on this one is a lot more difficult because I've got to take 2/3 to the 99th power and then multiply it by 2. So it is a little bit more limiting. We still probably need a calculator for that, but it's a whole lot better than trying to find the 100th term this way. All right, let's look at an example. So we're told that 3 is the third term and 48 is the seventh term of a geometric sequence. And what we want to do is define this sequence. So the first thing we have to do is we have to find the first term, the common ratio, and the explicit rule. So there's a few different ways that we could do this. There's very intuitive ways, but there are also more specific ways that we can do it. So notice we do know that it is geometric. So going from the third term to the seventh term, I have to actually go to the fifth. So from the so I have to go fourth, fifth, sixth, seventh. So I actually have to go 4 steps to get from the third term to the seventh term. So that means that I would have to take my common ratio, if I want to think of it that way, 3 times my common ratio to the 4th power would be 48. That's one way you can look at it. So I know that 3 times my common ratio to the 4th power is going to be 48. I can solve this for the common ratio. So divide by 3, r to the 4th is equal to 16. Take the 4th root, and I get r is plus or minus 2. And I do have to be careful because it could be plus 2 or it could be minus 2. Okay, it is possible that I could be switching signs each time. So it could go that 3, and then the next one could be, if I'm multiplying by negative 2, the next one would be negative 6, and then I multiply, then it'd be positive 12, and then negative 24, and then positive 48. So it could be a negative 2 in there. If this is an odd value, I'll know whether it's positive or I'll know that it's got to be one or the other. So the first term I can find, I know is going to be 3 over 4 because I'll go backwards. If the third term is 3, then I know that I had to go, to get from the first to the third, I had to go 2 times. So basically what I have to do there is divide this by 2 to the 2nd power. So I'll divide it by 4 and I get 3/4. And I can check that and make sure that it works. So there's my first term. There are my 2 possible common ratios. So here are my 2 possible explicit definitions. If it's positive 2, it would be 3/4 times 2 to the n minus 1. Or it's negative 2, it would be 3/4 times negative 2 to the n minus 1. All right, your homework is 21 through 34, all of those. So go ahead, and we will have a Zoom session this afternoon if you have any questions. Okay, hope things are going well, and we'll see you with our next video tomorrow.